Hey guys, welcome back to my channel. We're back in London and we're going to do a quick video today on something a little different. The last few videos have been quite intense and we haven't quite finished that yet, but I just want to cover a slightly different angle. It's kind of like a one-off this week, which is to talk about one of the other applications of blockchain that is, it still happens to use Bitcoin as the underlying protocol, but the usage of it is not really for the sake of payment. It's actually starting to explore some of the other benefits of blockchain and also to give some idea of how blockchain might itself revolutionize the way so many things are done, right? So
Okay.
So we're gonna come back and talk about and finish off the stuff about transaction inputs and outputs last week, which was a very heavy couple of videos. This one is I'm just going to cover this as a little bit of an aside and a little bit of a break, right? So the title of the video is proof of existence, right? So proof of existence, I guess it's fairly self-explanatory, right?
Yeah.
It's basically, how do I prove that a certain thing, and in this case, being a digital world, we're talking about a digital asset. So it could be it could be a picture, a document, a movie, whatever. How do we prove that existed in that particular form at a certain instance in time, right? And this has all sorts of potential sort of uses. One, I guess you could think about, let's say, you could verify that a particular document had been created prior to a certain date, and you could even admit that evidence in court potentially, right? So a couple of years ago, I was looking to buy a flat, right, in London. It never went through, but one of the things that everybody who's ever bought a flat in the UK and probably elsewhere in the world, depending on the process, you'll be familiar with the idea that every time you go through the purchasing process, you have to pay a solicitor quite a lot of money to essentially dig up documents, various documents, and one of them is environmental searches about the property, right?
Yeah.
And this is the kind of system that is inherently incredibly inefficient and it seems to just be a cash cow for solicitors, but it's the kind of thing that blockchain may well completely revolutionize, right? As in, it's and the whole process of sort of sourcing and archiving documents and validating that they haven't been altered since a certain time, and all that kind of stuff has huge potential. Now, this was the document that I paid quite a lot of money to have produced. As a standard document. It cost a few £100, right? And now it's dated obviously 29th of October 2013. Okay, so a little while ago now. And what if I wanted to ensure that this document existed in this very state, right? So basically, that including all the content, right? I wanted to ensure and prove beyond reasonable doubt that that document exists at a certain point in time. It's too late to do it for 2013 now, right? We could have done it back then, but I can do it now, right? What if we could do that? So we've got our document here, right? And if we can actually hash that document, right? Take the hash of it, and then somehow embed that hash in a Bitcoin transaction. We just use the Bitcoin transaction as a vehicle, right? Because Bitcoin transactions are, as we know, that we have a network that validates them. We have a blockchain that mines them into blocks, and those blocks stack on top of each other. And after a certain period of time, 6 blocks, it's basically that transaction ledger is basically completely and utterly unchangeable for all time, right? So we have those transaction documents as vehicles, right? If we can actually just find a way to slot that hash.
Blockchain as a vehicle.
Well, the Bitcoin blockchain. So the Bitcoin transactions, which are stored in the Bitcoin blockchain, right? Those transactions themselves are these little sort of mini documents with inputs and outputs, right?
Mm-hmm.
And if we can find a way to actually embed this hash of this document in one of those transactions,
Yep.
the transaction itself and the Bitcoin network will take care of the process of, validating it, mining it into a block, and then that transaction will be part of history,
Mm-hmm.
and therefore that will be proof that that particular hash existed at the time that because the blocks have a timestamp, right?
Right.
So you can see that hash must have existed on or before that timestamp, right?
Right.
There's no possible way that it could be otherwise, right?
Mm.
And that's all based on the fact that, as you know, right, no two documents can produce the same hash,
Mm-hmm.
right? It's just statistically impossible. The hashes are they're such big numbers, right?
Yeah.
That it's basically impossible to do that, right? So there's a really cool website, right? It's called proofofexistence.com. So I'm just going to show it right quickly, and we're going to upload this document and show how you actually get this working,
Okay.
right? Okay, so here we are. We've got this website. It's called proofofexistence.com. So you guys, I would sort of urge you to play around with this. It's kind of fun to see it in action, right? Because you can see your real examples in the real Bitcoin blockchain, right? You can take a photo or anything, and you can basically prove to all your friends that it existed. You probably find that less exciting than I do.
Probably not. You're not going to be very cool in your group of friends.
Depends what your friends are. Right.
Suppose.
So this proofofexistence.com, the idea is very simple. You take a file, okay, any file on your local system, okay, and what happens is the hash of that file is calculated, and there's a message here that says, reiterates, the file itself is not sent to the proofofexistence.com servers. It all happens locally on your system, right?
Yeah.
So what happens is the SHA-256 hash of whatever file you drag into this box is calculated. That hash is then going to be processed by these guys. It's going to be sent to proofofexistence.com, and they are going to process that. They're going to insert that hash into a Bitcoin transaction, right, which you're going to pay for, right? And
I'm going to pay for.
Yeah, using the Bitcoin that I gave you a few weeks ago, right? Okay. So basically, I'll show you exactly how this works, right? So if we click here in this box, right, I'm going to find my environmental search. So here's the hash, right? This is a SHA-256 hash, so it's basically 64 hexadecimal characters.
Yeah.
Right? So want this document certified by decentralized proof of existence, right? We can embed the documents digest, which is the hash, right, in the blockchain for you. The Bitcoin blockchain, right? That's what these guys do. You'll need to pay 5 millibitcoins to do so to cover our costs.
And how much is that more or less in pounds?
It depends on the prevailing rate.
More or less.
Bread Wallet will show you in a second, right? Okay, so now we're just going to use Bread Wallet, right?
Yeah.
On the phone, which you guys can't see, but we're going to scan this QR code on the screen. There you go, right? Touch. Can you touch with your thumb?
It's £2.90 something.
So now you can see, congratulations, this documents digest was successfully embedded in the Bitcoin blockchain, right? And basically it's now permanently certified and proven to exist since the transaction was confirmed, right? So the question now is, let's just actually have a look at this, right? So if we see. So this takes you to the actual Bitcoin transaction. Now you can see, obviously, it's as yet been unconfirmed, so it hasn't yet been mined into a block, right? So that's the usual thing. You normally have to wait. It's pending, so I guess maybe in like 10 minutes or so, you'll see it in an actual block. At the moment, it's unconfirmed, but you can see, and this is going to be basically the remainder of the video, is to talk about actually how this hash actually made it into the transaction, right? And the answer is that there's a special Bitcoin output called op return, which is it's just a field in the output of the Bitcoin transaction, which allows you to put in up to 40 characters of whatever information you want, right? So the reason this happened was because people early on decided, yeah, actually this is really cool. We can use the Bitcoin blockchain to prove the existence of certain hashes. But what they did initially was they actually used the hash of that document as the Bitcoin address of the transaction, right? So obviously the effect of doing that is basically that means that transaction is basically being spent into thin air, because you're paying. Nobody owns that Bitcoin address, right? If we took the document, right, that we just hashed, right, and we took that hash and basically made a Bitcoin transaction that was basically just payable to that hash as the Bitcoin address. Nobody owns that Bitcoin address, so nobody can spend that transaction output in future. The only benefit of doing so is that, yes, the transaction is there on the blockchain, and so there's a record of that hash existing at some point in time, right? But there's no way for that Bitcoin to ever be spent in future, because it doesn't correspond to an actual public and private key, right?
Okay.
Right. So they wanted to discourage people from doing this, and the reason for that is that
Who is they?
the Bitcoin developer community, the people who develop and maintain the software.
The miners, isn't it?
Well, yeah, it can be anybody. I mean, the Bitcoin project is open source, which means that anybody is free to download it and edit it, etc. But once in a while, there are sort of the community as a whole agrees on certain enhancements to the software, right? That are standard, right? So there'll be a new version of the software released, right? Which people are free to download or not download as they want, but the point is, they didn't want people to use these hashes as actual Bitcoin addresses, and the reason is because having this pool of Bitcoin that can never be spent in future, ever, right, just means that the miners, they have to maintain in memory, right, on their mining computer, they have to maintain a pool of all the unspent transaction output, right? And so because this particular transaction output can never be spent, that pool in memory just gets bigger and bigger and bigger and bigger, and that causes problems for the miners, because that now this pool that exists in memory on the system is taking up so much memory. So what they did was they said, okay, if people really want to use the Bitcoin blockchain to include hashes to prove things existed, right? Or you can put messages. I think you've seen like some silly messages that are put in as well about Piper and stuff, right? So they said, what we're going to do is we're going to have a special type of output that you can include in a transaction, right? And it's called op return, right? And after op return, you basically include 40 characters, whatever characters you want, right?
What does op return stand for?
Well, op is operation, and return is basically it's just the name they gave to this particular instruction in the output script.
Okay.
It basically says whatever comes next, right, after this, do not treat it as a Bitcoin address. You cannot you can't pay Bitcoin to this particular address. This is not an address. This is just a message, right? Just a message. So, and in this particular so we've got two outputs in this transaction. The first one was the output that paid for the 5 million Bitcoins, right?
Yeah.
That's actually paying for the transaction. And then the other output is just this op return. And the op return contains, embedded in there, it contains the hash, right, of the it contains the hash of the document, right? So if we just actually click on this, Okay, it's still unconfirmed. So does that make sense so far? So
Yeah.
you got your document here, right?
Yeah.
You put the document through a SHA-256 hashing algorithm, right? That gives you the document hash.
Yeah.
Right? And then what you say is, we create a new Bitcoin transaction, and as always, Bitcoin transactions have inputs and they have outputs, right?
Yeah.
And then basically the outputs, well, we have one output which is basically it's just a standard output that basically pays, because every Bitcoin transaction you have to include you have to pay Bitcoin to actually have the transaction mined into a block, right? So you have and then the proofofexistence.com have a small charge, right, that they collected. So that's the standard output for the fee. But then the other output you've got is the op return, okay?
Yeah.
And sorry, not returns, op return, and then after this you have 40 bytes, right, or 40 characters, right? So 1 byte is a character, so basically either a number or I'm not going to go too much there, but so you can and that can be whatever you want, right?
Yeah.
So and then as you know, like what happens after that, right, is that this transaction gets sent all over the Bitcoin network, right? Gets propagated, validated, right?
Yeah.
Across all these nodes, and then let's say one of these nodes over here is a miner, right? And then in about 10 minutes, this guy is going to successfully mine this transaction into a block, right? So at that point, this transaction is going to be in the most recent block in the blockchain.
Yeah.
And then let's say in a few more confirmations, this transaction in here is basically
buried.
Is buried so far, and it's just a standard Bitcoin transaction. But the point is, you can search for that transaction in the blockchain, right? And you can check the timestamp, and you can see that the hash is there.
Yeah.
Right. So while we're waiting for it to be confirmed, there's one thing that I wanted to actually get across, and it came up when we did this, and it said, please transfer 5 milli bitcoins. Right. I want to, just in case anybody's wondering, there's actually quite an interesting question, which is, if these guys are charging 5 milli bitcoins for some transaction, and let's say they're receiving hundreds of these a second, how on earth do they know that basically that your payment has just come in, right? Because Bitcoin is anonymous. There's no from email address or name. It's an anonymous or pseudo anonymous protocol. So the question that might be in some people's minds is, how, if they've got 10 transactions coming in every minute for the same amount, how do they distinguish them? How do they know that, okay, this person has paid and this person hasn't paid? And the answer is that they use a different Bitcoin address for every transaction, right? If I just take this file here, right?
Yeah.
It's created the hash, it's redirecting to the payment page, and it's saying, please send 5 milli bitcoins or more to this Bitcoin address, right? Look, it ends in ZUA, right? I'm not going to bother with that, but it ends in ZUA. But I'm going to go back to the website again, and I'm going to do another one, like this one. So it's hashed that document, and it's redirecting, and now it ends in TUW, right? So it's using it's generating its own. It's regenerating a new Bitcoin address for every transaction, right? Because I think we discussed this in the past. Your wallet can contain as many addresses as you want, right? You can, and the recommendation is actually to
have a new one
have a new one every time, right? And as long as you've got the private key and the public key, you can have as many pairs of those as you want, right? So that's what's going on here. This is how proof of existence know that basically this document here, so this transaction that they're providing a service to me, right? And so they need to know, before basically providing this service, they need to know that I've actually paid it, right? So, and the fact that they use a different Bitcoin address for every transaction means that that they can easily identify, because they just have to wait for the transaction to appear, on the network, right? With this Bitcoin address as the recipient, because there's only one transaction like that, because they're only using it once.
Yeah.
Right. So that's an interesting little aside that I think can be a bit confusing at first, right? So one other thing is, so if you want to verify in future that this document has been, its hash has been stored in the blockchain, if you ever try and repeat the process for the same document, then proof of existence, the website, will actually go ahead and it says, see, file already exists in the system, redirecting. So it gives you a nice little message saying, congratulations, this document digest was successfully embedded in the Bitcoin blockchain. It's now permanently certified and proven to exist since the transaction was confirmed, right?
Okay.
And that's the transaction ID. So then you can click on that transaction ID anytime you want, and it'll take you to the place in the blockchain where
the hash of it is stored.
Yeah, exactly. And it's stored in the op return output, right? Okay, so this is taking a while to get confirmed. So we'll probably just wrap it up there, and I'll put a screenshot at the end when it does get confirmed. But that's the first kind of an introduction into op return, right? And how it can be used to basically encode and include small pieces of information, even messages. And in this case, we can use it as a proof of existence by storing hashes in the blockchain, right? And if you think that think about the use case where I had environment searches for a property, and you think, why on earth is it necessary to actually pay for every single person who's interested in buying that house to do this, to pay the same amount of money to get the same document? Surely in future, and this is where blockchain could come into its own, if there was a way to essentially keep that document somewhere safe, but in a distributed way, and there's something called the
P2P network.
Yeah, exactly. So there's a network called the Interplanetary File System, IPFS, and that's really exciting, because what it does is it takes files, okay, and just like in a similar way to some of the other P2P networks and torrents, right? You split the content up into small chunks, and then you store them on different servers all around, right? And there's some redundancy, so there's some duplication, right? So you don't rely on any one particular server. But then, so if you paired that with this, the blockchain, what it's doing here is basically saying, yeah, this hash, if you give me this file, I can prove that this file existed in this state at this point in time. But it doesn't actually store the file, right? You still need somewhere to actually keep the file. And so, and if you want that to be, sort of decentralized and distributed, then you need a way to actually to store the file, and that's why IPFS, Interplanetary File System, is a very exciting idea. And I'm going to cover that in future videos, right? Because there are so many of these kinds of things that I think are set to be revolutionized by blockchain, right? And this arcane kind of paying for documents that already exist, right? And not having access to them. I mean, why should it not be public? Why should the environmental data about this flat not be available publicly, right? So that's in the next video. I'm going to show a fun little way on how to use the opreturn thing to encode your own serial messages, right? So it's another bit of fun, just to try and build familiarity with, I guess, some of the other things that the blockchain can be used for. So that's the next video. I'm going to show how you can actually, instead of putting a document hash for proof of existence, you can just put a little cute little message in there, right? So thanks for listening, thanks for watching, and as always, please like and subscribe if you liked the video. If you didn't, then please leave constructive feedback, and thank you for watching. I'll see you in the next one. Bye.
Bye. Ciao.